Aloha is a random access protocol which was actually designed for wireless LAN, but it is also applicable for shared medium. In this, multiple stations can transmit data at the same time and hence it can lead to collision, and data will be garbled if collision occurs. There are two types of Aloha, Pure Aloha and Slotted Aloha. And the topic of the day is Slotted Aloha. Before going into Slotted Aloha, we will just revisit what is Pure Aloha. In Pure Aloha, any station can place their frames on the medium, that is the shared medium, at any time. So station 1 is placing here, and station 2 is placing here, station 3 is placing here, and station 4 is placing here. So this placement of frames on the medium, that is on the shared medium, is random, and whenever any station has the data, it just places. And if you observe, the collision duration is also not uniform. Here we have a big collision duration and here a small collision duration. Here we have two or more frames that are colliding with each other. Here only two frames are colliding with each other. And the vulnerable time here is 2 times of the frame transmission time. Let's now see what is Slotted Aloha. The Slotted Aloha was developed just to improve the efficiency of Pure Aloha, as the chances for collision in Pure Aloha are high. If you can recollect, the throughput of Pure Aloha is 0.184 and we want to improve this efficiency here, and that is why we are in Slotted Aloha. And the time of shared channel is divided into discrete time intervals called slots. In Slotted Aloha, the entire channel is shared in terms of time, whereas in Pure Aloha, we don't have anything like time slots. Then why do we need these kind of time slots here? The sending of data is allowed only at the beginning of these time slots. Suppose if the entire channel time is divided into 6 time slots, the sending of data can happen only in the beginning of the time slot, maybe in the time slot 1 or 2 or 3 or up to 6. The important point to note here in Slotted Aloha is the sending process can happen only at the beginning of these time slots. Let's see it with an example. Here let's assume there are two time slots, time slot 1 and time slot 2. Station B is placing its frame here and station A and station C is placing its frame here. So if you observe, the sending process can happen only in the beginning of the time slot. In Pure Aloha, any time it can send. So it will be here, it will be here, it will be here, it will be here. Whereas in Slotted Aloha, the placement of frames happen only in the beginning of the time slot. So this is the beginning of the time slot 1 and this is the beginning of the next time slot. So frame A and frame C are placed in the beginning of this time slot. So this can lead to collision because A collides with C. There is nothing like the beginning of A is colliding with the ending of C or ending of B is colliding with the beginning of A. This will not be the case because any frame, if it wants to be transmitted, it will be only in the beginning of this time slot. So if you observe, the vulnerable time here is the frame transmission time, because if two frames are getting collided, it means these two frames are in the same time slot. How this Slotted Aloha differ from Pure Aloha? So there is nothing like time slots and frame can be transmitted or placed on the medium at any time. B's frame is placed here, A's frame is placed at this time and C's frame is placed at this time, and that's why the vulnerable time is 2 times of the frame transmission time. Whereas in Slotted Aloha, we have time slots and sending is permitted only in the beginning of the time slot, and that is why the vulnerable time is the frame transmission time. Let's continue dealing with Slotted Aloha. If a station misses out the allowed time slot, it must wait for the next time slot. This reduces the probability of collision. We will see it with an example. Suppose if station wants to place the frame at this time slot, but it is missing out, so it can't send the frame from this position or from this position, because sending is allowed only in the beginning of the time slot. So it has to wait till the beginning of the next time slot, and sending can happen only in this time slot. And that's what it is mentioned here. If a station misses out the allowed time, it must wait for the next time slot. This reduces the probability of collision. We will see the formulas for Slotted Aloha now. The vulnerable time is the frame transmission time, and we have already seen that. And the throughput here is G into e power minus G, where G is the number of stations wish to transmit in the same time. How this formula differ from Pure Aloha? In Pure Aloha, the throughput is G into e power minus 2G. And here it is G into e power minus G. The maximum throughput in Slotted Aloha is 0.368 for G is equal to 1, whereas in Pure Aloha it is 0.184 for G is equal to half. Let's understand Slotted Aloha with the help of a neat diagram. So here there are 4 stations, station 1, station 2, station 3 and station 4. As usual, these 4 stations have a common channel and any station can transmit at any time. It is obvious because the Aloha protocol itself is any station can transmit data at any time. But in Slotted Aloha, any station can transmit at any time, but only at the beginning of the time slot. How many time slots are here? Slot 1, 2, 3, 4, 5 and 6. In time slot 1, only station 1 is placing its frame on the medium. So there is no chance for collision because station 2, 3 and 4 are not involved in the placement of frames on the medium. Whereas in time slot 2, station 2 and station 3 are placing their frames. And what is the collision duration here? It will be the entire time slot. In slot 3, station 1 and station 4 are placing their frames, and in slot 4, only station 2 is placing its frame. Slot 5 and slot 6, station 4 and station 3 are placing their frames respectively. So, slot 1, slot 4, slot 5 and slot 6 there are no collisions. Whereas in slot 2 and slot 3 there are collisions. The collision duration is the time slot duration. Whereas in Pure Aloha, the collision duration will be varying. Because any time the frame may start in Pure Aloha. Whereas in Slotted Aloha, it can start only in the beginning of the time slot. Let's now compare Pure Aloha and Slotted Aloha. In Pure Aloha, any station can transmit the data at any time. Whereas in Slotted Aloha, any station can transmit the data at the beginning of any time slot. In Pure Aloha, there is nothing called time slots, so the time is continuous and not globally synchronized. Whereas in Slotted Aloha, the time is discrete and globally synchronized. We know the vulnerable time in Pure Aloha in which collision may occur is 2 times of the frame transmission time. In Slotted Aloha, the vulnerable time is frame transmission time. So the vulnerable time is reduced to half. The probability of successful transmission of data packets or frames in Pure Aloha is G into e power minus 2G, whereas the probability of successful transmission of data packet in Slotted Aloha is G into e power minus G. The maximum efficiency is 18.4% because the throughput is 0.184 and it occurs at G is equal to 1 by 2, that is G means the number of stations that wish to transmit at the same time. Whereas the maximum efficiency in Slotted Aloha is 36.8%, which occurs at G is equal to 1. That is, the frame transmission time is the vulnerable time. And if we observe, the maximum efficiency is 18.4 in Pure Aloha, it is doubled in Slotted Aloha. And that is why the first point what we have seen in the Slotted Aloha is, it was just developed to improve the efficiency of Pure Aloha. And it has improved. And the last point in the comparison is the advantage. The main advantage of Pure Aloha is simplicity in its implementation. Whereas in Slotted Aloha, the main advantage of Slotted Aloha